welcome everyone, and we will explore Slint as a Rust alternative to QML for graphic user interface development. And I'm David Vincze, I'm from Felgo, and before going into the actual talk, just a few words about what we do at Felgo and myself. So at Felgo we do development for embedded mobile, desktop and web. We do development services, tooling, training and consulting, and cross-platform HMI UX development. We've been doing this for more than 10 years as a certified Qt partner. The main office is located in Vienna, Austria, but we also have offices in Linz and Cluj in Romania with a team of 35. About me, I'm David Vincze. I'm a software engineer at Felgo. I am from Cluj-Napoca, Romania. My background is in C++ and Qt, in automotive industry, working on instrument clusters, mostly the entertainment part, and HMI navigation. And the Rust hype train caught me as well, with Rust being so amazing, like I think every one of you think like that. So that's what led me to explore Slint, as it's really similar to QML and it can be used with Rust. So how many of you actually know about Qt and QML? Yeah, so many. So it will be easy for me. I don't need to say that much. So QML is like Qt's modeling language. It's a really mature language, so it's been around for more than 10 years now. And it's a declarative language with a JSON-like syntax, so you need to add nodes of object in a structure, and you have there the visual items and their behavior with JavaScript logic sprinkled on it. And this is all reactive, so you have the properties, bindings, and signal handlers and connections to it. And the advantages of the QML is that you can write a single code in QML and run it everywhere. So it is supported for multiple platforms. It is fairly easy to learn and to use. It is fast to prototype. So if you want to do some coding, you just need to start up. You write a few lines, like you can see it there for rectangle, and you are already done. It's easy to maintain, and all of it is testable with UI tests and unit tests as well. But there are also risks and concerns for QML. So mostly there are performance concerns, as the QML is using JavaScript logic. So JavaScript is mostly runtime interpreted. And if you are not actively working on optimizing your code up front, then you can pretty easily get into troubles. And also, you are committing yourself to the whole Qt ecosystem and their tooling, and C++ as well. And there are also worries about licensing costs for bigger projects as well. And so we look at alternative, and Slint is fairly similar, and it's a new language, new toolkit for Rust, and it was released, the first 1.0 version, a year ago. So compared to QML, it's really new. It's built with Rust, and it has APIs for multiple languages like Rust, C++, JavaScript, and even Python, but that's in alpha. It's declarative as well, similarly to QML, but the major difference is that it gets compiled to native code. So your errors are caught at build time instead of runtime. And this is reactive as well, because you have property bindings here, and you have callbacks instead of signals, and you have a lightweight runtime, since it was developed with taking in consideration the embedded systems. And I'm happy that Oliver's presentation was before, so you already saw and know some things about Slint and how it looks, how it works. So we will compare it a little, the QML and the Slint, and see what are the major differences and similarities, and how hard is to learn Slint coming from the QML world and knowing QML. So we did this by learning by doing. So we actually implemented a demo application that you can see at the Felgo booth. It's a weather application and home automation UI. By implementing an existing idea, there is a weather application written in QML with Felgo SDK as well, available for Android and iOS. And we re-implemented all of this from scratch using Rust and Slint. And it is multi-platform, so available for desktop, embedded. It is running on a Raspberry device and Android as well, with an adaptive layout, and all of it is open source. So if you want to take a look at the code and maybe give us some tips on how to improve it, you can find it on the Felgo SDK's GitHub repo as a Rusty Weather app. And you can always come at the booth while you're still here and test it yourself. So let's get into the actual comparison. So the structure of the code is pretty similar. As you can see on the left side, there is the QML code, and on the right is the Slint. They are both producing the same window with a rectangle in the middle. And the Slint code is more compact. You can see it on this example, but you will see it later. As both of them have their building blocks, the components, and the major difference is that on QML, you either create a new file for component and implement it there. The file name will be used as a component name, or declare the component type and use that from loaders or list views or anything else, or define it in C++. While in Slint, you create a component in the Slint files by defining a component and your component name. You can export this, and this can be accessed from native code compared to QML created components that are not accessible easily from native code. Yeah. For structures is a basic building element, and there is support from Slint to structures that is defined in the Slint code, and it gets compiled to native code. As you can see it there, this is how it would look. And these structures can be used from Rust or the C++ API, whatever you are using Slint with. But for QML, it's a little more complicated because this concept doesn't really exist in the same way. You can mimic the structures by adding properties to a most basic object, the Qt object, and use that, or you can define it in C++ and adding properties there. So it's the same way if you want to integrate your C++ code with it. But you need to write a lot more boilerplate code that way. So yeah, the properties are present in both of them. With they look the same. The read-only is the out property, the required is in property, and the default property is in-out in Slint. The major difference is that the QML properties need to be, well, they can be typed or typeless as well. And on Slint, you need to use either a Slint internal type or your custom structure or custom type. And the Slint basic type values have also suffixes. So for length, you use the pix suffix, and for angle, the degrees, and so on. And the property change notifications. So what are these? In QML, you have a signal emitted every time you change a property, like the property counter change in this case. And you can react on this using signal handlers like on property changed, and you do something. Initially, when we first looked at Slint, this wasn't there, but officially. So there is an experimental feature, and you can do the same thing as well here using the changed counter or changed property syntax. So it was really nice seeing how fast it evolves, because as the first look, it wasn't there, and we were looking for workarounds, and just then a pull request popped up, and it was there. So, yep. For functions, Yeah, both of them support functions. The major difference is the QML functions are actual JavaScript functions, and the Slint ones are Rust-like functions. So the QML functions are not typed. You can give any type of input parameters. You can also type it, but it's unsafe as it can return anything, and it's lazily evaluated. So you won't know your error until you use it runtime. So like a function of adding 2 values adding 1 or 2 can give you back 12. And you can mix of integers and strings as well. In Slint, the functions are typed, and you need to specify the types similarly to Rust while defining a function, and the return type needs to be defined as well if you return something. And this is evaluated at build time, so you will know if you have problems with your functions. The signals and the callbacks, they are coming from the same idea, implemented a little bit differently, since in QML you can declare signals manually or either use the implicitly declared signals for properties. And the signals actually cannot return a value, and if declared in QML, you can hardly use it in C++, but if you declare it in C++, you can use it in QML. So yeah, that's it. And but the difference is that on signals, you can have multiple signal handlers. So for your signal, you can react on multiple places, while Slint's callback is similar to signals, but it can return a value. It is accessible from native logic as well, easily, but can have only one handler. So if you add a new handler, it will be overwritten by the new one. As singletons, people don't like singletons in general, but in UI, you need sometimes singletons to represent the actual application state that is general in the whole application. So in QML, you either define a pragma singleton in the file that use it only in QML, or define your C++ object with some macros, and that can be used from the whole application. While in Slint, you export a global component with some properties and callbacks, and this can be accessed globally either from the native code or Slint code, and you can react on this with, there you can see some syntax on how you use it from Rust, for example. Yeah, for repetition, in QML, you have this repeater element, component, where you just give a model that you want to repeat n times. Here in this example, you see just a simple rectangle repeated 5 times, and it's similar in both of them. So you have the same idea in Slint with the for in looping in a model or a number, where both of the codes will produce 5 rectangles in these cases. So this is pretty similar. As for dynamically loading your components and conditionally loading and not using something, in QML you have this loader type that can dynamically load other QML components, either synchronously or asynchronously. And you also have progress tracking that most of the time doesn't make sense because everything is loaded instantly. If you have bigger components, yeah, sure. And the source component can be changed dynamically. So for the loader, you can actually modify your component runtime, and in the same place it will be loaded another one. In Slint, you have this conditional element. Then, for example, an if a condition evaluates the true, then the element, your component will be rendered, created. But the downside of this, well, you can consider it downside and positive as well, that you know it at you need to know it at build time. So you need to actually know what you will use. It helps you maybe not creating so many bugs in this case. As for the states, they are pretty much the same as well, as you define a list of states, application states, in both of them. The difference is that in Slint, a state is applied when a condition is evaluated to true, and in QML you can either add a when condition, and if this evaluates to true, then that state will be chosen, or you can manually set your states, and the state can be bound to a property and modify this. Also, you can set transitions for both of them, with the major difference is that transitions in Slint are directly linked to the states. So you have the in when you come into a state, and when you go out to from a state, you do, I don't know, some animations or property modifications. While in a QML, you need to define a list of transitions where you define the from which state you come to what other state, and there you define your animations. It is more dynamic. You can implement some additional switches, like switching from one state to the other to behave differently. And yeah, it's not as compact, but maybe give you more flexibility in this case. So animations are present in both of them. QML has a little more support for different kind of animations. That it's normal because it's been around for such a long time, and the major difference is that in QML you can manually start an animation and stop an animation, or you can apply directly to the components, and you can have these behavior objects that animation will be run when the property changes. This is the same in Slint, because you animate, let's say, with a property, and the animations will be run when this property changes. But for permanent animations, like, I don't know, a spinner running all while the application is running or loading, you have to use this animation tick in a property binding. So when the animation tick gets evaluated, the whole property binding reacts to it, and that's how the animation will be run. And in QML, you can actually give an animation like looping infinitely separately. So you have possibilities in both of them to animate things. As for renderers and backends, for QML supports most of them. So you have this cute rendering hardware interface that will actually render the graphics to either OpenGL, Vulkan, Metal, or Direct 3D, or you have software renderings and OpenVG. While in Slint, you have the default renderer for Linux is a Qt based on QPainter. It's a software renderer. But you also have the Vincze backend that can support either software rendering or FEM2VG with OpenGL and Skia as well for the other platforms renders. For translation and localization, Qt uses its own internationalization framework that is included with the whole Qt package. It has several different tools to handle the translations, like generating the binaries and managing the translations files. It is well documented and supported on all platforms, and the languages can be changed dynamically. So you just get your translation file for either the code or the translations, which will be compiled in a QS file, and that is used in the app. While in Slint, this is a little more complicated at the time, because it uses an external library, the getText, which is not supported on Windows and the platforms that do not have this library. And it has multiple manual steps, and you need to use some third-party tools to get the translations here. So in this case, maybe QML translations are better handled. As for IDEs and the toolings, from QML coming from the big Qt, you have the Qt Creator and Qt Design Studio for editing and viewing your QML code with dragging and dropping, and you have plugins for the major editors, and multiple tools like Squishk for UI testing or Gamma Ray for getting more into the in-depth of what's happening at rendering, or we have this Felgo hot reload tool that actually reloads your code live. As for Slint, there are also extensions for major editors, and I really like the Slint's VS Code extension way more than the other ones. It is, as you have seen it yesterday, it is so intuitive and helpful that you can use the live preview as well with Slint and see your code modified actually live. You don't need to recompile everything and lose your time waiting. So, yeah. So, how hard is switching to Slint coming from QML, and what are the benefits of it, or pitfalls and challenges? The benefits are that Slint is fast growing. You see new features and new releases like monthly or 2 monthly from what I have shown. You have all the benefits that come with Rust, as the memory safety. You catch the errors build time, and you have a great package manager, Cargo. It is multi-platform, and it is really easy to cross-compile. Most of you know how easy is cross-compiling Rust. It has a better modelization since the code is more compact. You can organize it better. It has API for multiple languages. You are not limited to C++. You can use Rust or other ones, and you can integrate it easily with your native code. And the Slint viewer helps you write your UI code. It speeds up the process. But there are also challenges coming from QML, and comparing it to QML, as you are lacking some of the extended features that QML provides, like the multimedia support is better, and maps or canvas, or having internal timers like in QML, or 3D support and multi-window support are still in progress, planned, or I'm not sure, some of them, if they are planned for Slint or not. And you currently have no automated UI testing, but from what I had some discussions with the Slint guys, and I heard that they are working on some UI testing. So this will be not for long until we have UI testing with Slint as well. And debugging capabilities because of this is also limited. And you don't have support for iOS yet. So should you switch to Slint? Well, that depends on what you want to use Slint for. I would say yes, if you want to go with the full Rust solutions, because for me it seems that the Slint is the best toolkit currently for Rust and GUI, and it has a huge potential in the future. It has more predictability compared to QML, since you can find your problems before actually deploying your code and just seeing it live that something is not working. You got the errors at build time. It has a better portability, since you can cross-compile easily. You are not so tied to the whole framework like in QML case. For embedded development, it has a really good performance, and if you want to be part of an evolving community and escape the Qt system, it is one of the best alternative. So that would be it from my side, and if you have any questions.
Thank you, David. I think there's one question over here already. Did I? No? Did I see a hand go up in this direction? Oh.
Hi, thank you for the info. Just one question about the language. You mentioned that there's some difficulty in multi-language support. Maybe I missed the details. Is it not possible to switch languages, or it's just harder to get multi-language support?
Are you referring to the translations?
Yes, translations.
Yeah, it is possible in both cases to have multi-language support. It is more difficult to implement it currently with Slint that is using the getText library.
Any other questions for David? No? Well, I have one. You're working from QML and you're moving into, or you're doing QML and Slint. How are you sort of doing a transition? Are you rewriting codes to sort of eliminate that dependency that you talked about at the beginning of your talk, or is it just something that you're now adopting Slint for new development?
Yeah, we are mostly adopting Slint and exploring it as alternative, so to use it in future projects with Rust, because it's way easier to use it with Rust than, let's say, QML, where you need to have bindings to Rust.
So Felgo is going to become much more efficient in the future then?
Yeah,
yes,
I hope so.
Great. Thank you so much for your talk, David.
Thank you.